Hi, welcome to Zeta Services. In the playpen today we're going to talk about tech tips, and we'll do a series of them because there'll be some information that you might find useful. We'll be looking at this brute of an amplifier today, a big old valve amplifier. Main reason is because I want to show what happens when we look at high voltages using a scope when the probe is AC coupled, and you then go on to measure other voltages in that circuit which you could damage because of the charge that sits on the probe, and what you can do to get rid of that charge when you're looking at the various different voltages going from HT down to very small voltages, especially on transistorized circuits and so on and so forth. So something that I learned when I was doing my training days at GCHQ. I can't tell you more than that, otherwise I'd have to shoot everybody that watches the video. But we'll turn this over, have a look underside, and take it on from there. Right, we've got this beast of an old amplifier. It's in a sorry state. It's 120 watt, 6 output valves, very nice when it was brand new. Because it looks, the output's awful and the customer's complaining it's all distorted, the first thing I want to do is to have a look around and see what's happening on the output stages. So a quick look at the anodes of the EL34s, the output valves. Of course we do that, and they've got about 400 volt on them, so be careful. And of course on the scope you can't see anything because the trace has hit the ceiling, because there's 400 volt plus or minus. Now the good Lord understood this and gave us an AC coupling button, so he gets rid of the DC content so we can see the AC component, which is going to give us a clue. And we look at that, and there we go. Well, that's supposed to be a sine wave. It's clearly not, and there's a nasty problem with it. Right, so now we want to investigate further on, or before this valve arrangement. We look at the phase splitter, preamps and so on. But what we've got is this scope probe, because there's a capacitor coupling, is still charged at a couple hundred volt. Now if we were to put that on an early part stage of the amplifier, in this situation you get a nasty loud crack and possibly do a bit of damage somewhere. If you had a solid state component of this amplifier in the earlier stages and you wander around with that probe fully charged, you do some serious damage to the circuitry, and you'll be investigating a problem in addition to the one you've already got. So what you should always do, once you've measured your high voltage component, look at the scope trace, ground your scope probe, and you'll see the trace disappear to the bottom. Now that probe has got no DC charge left on it, and you're safe to investigate elsewhere. It's a little tip that I picked up years ago, GCHQ training, which was very good. I've fallen foul of doing this sort of thing, and I know other people have. The other thing, of course, which you don't do as I do as I say, don't wear metal bracelets when you're dealing with high voltages, and keep one hand tucked away so you're not bridging something across your chest, because that will stop your ticker. So conclusion, when you're working on valve equipment, take your metal bracelets off, one hand in your pocket, and if you're using a scope probe and you've got it AC coupled, whenever you finish measuring high voltage power lines or whatever you're looking at that's got a big DC potential on it, take your scope probe and earth it to the chassis to get rid of that charge before you go hunting around earlier parts of the circuit that can be damaged easily by a nasty spike of a few hundred volt. Good luck. Right. just a quick thanks to My TV Cinema and Gary West, aka Cecil B. DeMille, for filming this. We're going to do quite a few more. If you're going to find them interesting, then let me know. Cheers.
Thank you very much. See you in post-production.